Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel TanmoyChem. Today's topic of discussion is a very easy MCQ. The order of decreasing reactivities for those alcohols towards substitution reaction. I request you student, please pause the video, try by yourself, and whatever answer you get, please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now, what is the order of decreasing reactivities of this alcohol towards substitution reaction with HBr? By the way, if you look at this problem, you will be confused that sir, all are benzylic substrates, and we know benzylic substrates is efficient for both SN1 and SN2 reaction. But how can I decide what they have asked? Because they have written substitution reaction. Actually it's a nucleophilic substitution reaction. But student, look at here, it is told as HBr, alcohol plus acid. What happens? Alcohol reacts with OH and make its OH plus. After that Br attacks. Now how? But if you want to learn this, you need to have a little understanding about the mechanism. So first, HBr, it's a polar bond hydrogen bromine. By the way, said not only electronegativity difference, apart from that, hydrogen is smaller atom, bromine is bigger, so overlap is poor, bond is weaker. So HBr easily dissociates and produce H plus and Br minus. Okay, now this is the OH. Oxygen has two lone pair, so one of the lone pair can act as base. I repeat, oxygen is acting here as base, so it is acid base reaction to produce this OH2 plus. By the way, oxygen is an electronegative atom. It cannot carry permanently positive charge. Positive charge means deficiency of electron, that's not stable. So what will happen, that this bond will break and it will result one benzylic carbocation. Okay, and we know benzylic carbocations are resonance stabilized. How? With these benzene rings. So it will come and you can draw one canonical form. So this is CH2 plus. I suggest you student, you all draw all other canonical forms by yourself. What do I mean? You can draw one canonical form, so positive charge will come here. In next canonical form, positive charge will go there, again it will come there. So total 5 canonical form including this one possible. So what is the message? That this positive charge is delocalized into the benzene ring. So because of this delocalization or resonance, this positive charge is relatively stabilized. So you can say that benzylic carbocation is actually relatively stable. This is the thing. So if it is relatively stable, so it will preferentially follow the pathway of SN1 type reaction. So first carbocation generation and then nucleophile will attack this carbocation. So you may consider this is a SN1 type of reaction. Now you can ask me one question, that's sometime before you told they can undergo both SN1 and SN2. Yes, they can undergo, but you cannot compare this question with respect to SN2 concept. For that purpose, SN1 is the best option. Why? Because here nucleophile Br is same, HBr reagent is same. Where is the difference? Difference is actually on the substrate. Okay, and all these groups are in the para position. Just imagine. So steric effect point of view, if you think, you cannot compare, but you have to solve this question. So that's why you need to think that okay, I need to think this problem from SN1 concept. Sometimes such kind of problem comes which creates confusion, but I suggest student, this logic you should remember because you have to solve the question. Next, so this we understand here. Now one thing we're clear that okay, carbocation preparation is the intermediate. So this carbocation is the intermediate here. Now if the intermediate is relatively more stable, then corresponding energy of activation will be less. Now energy of activation for intermediate preparation will be less, so reaction can take place faster, because we know the Arrhenius equation K is equal to A into e to the power EA by RT. This K is the rate constant and A is the pre-exponential factor. This EA is energy of activation exponential, but there is a minus. So EA is less, K is higher. This is the concept. So from that, if an intermediate is more stable or relatively more stable, the corresponding energy of activation EA is less, reaction will be faster. So let's learn relative stability comparison of this all benzylic cation. By the way, they are benzylic all. Substitution pattern is different. There is nothing means there is hydrogen. Now if you look at the nature, so hydrogen is neither donating nor electron withdrawing, but NO2, it's a electron withdrawing group. Actually it shows both -I and -R effect, and both pulls electron density from this benzene nucleus, resulting in reduction of electron density in this ring. So if this ring is less electron rich, then it cannot stabilize this positive charge, because remember, positive charge means deficiency of electron. If the ring is already deficient, then how can it gives electron density to this CH2 and stabilize? So stabilization is lesser in case of option 2. Now look at the next option. So here this is a CH2 plus, but this is actually oxygen lone pair. By the way, I am drawing only one canonical form. I request you please draw this by yourself. There are many other canonical form possible, but I am drawing only that which is important for this point. So okay, the positive charge on oxygen participating in this plus R effect or resonance. Now this oxygen shows two types of, actually it is an electron donating group. It shows two types of effect, plus R effect and minus I effect. How minus I? Because oxygen carbon sigma bond is there and oxygen is more electronegative compared to carbon. And here the plus R effect is more dominant over minus I. So overall electron donation takes place. That's why I told it as electron donating group. So since it's donating electrons, so it's stabilizing this positive charge by this delocalization. You can see this canonical form. Okay, so this is stabilized. Now if you look at bromine, now it has a very unique criteria. This bromine has two kinds of effect. It can show both plus R effect. How? So this lone pair donation inside the benzene ring in this way I am showing, and minus I effect. Minus I effect, why? Because there is a carbon bromine bond. Since the halogen atoms are significantly high electron withdrawing groups, that's why the minus I is more dominant over plus R, and this halogen is weakly electron withdrawing group. Okay, means if I say who is maximum electron withdrawing between bromine and NO2, obviously NO2 is more electron withdrawing because both of the effect are withdrawing in nature, minus I as well as minus R. But in case of bromine, minus I plus R works opposite direction, but minus I is more dominant. So these ring, you can say, slightly electron deficient. If it is slightly electron deficient, so you can expect, sir, stability of this positive charge is slightly less compared to unsubstituted one. Okay, now here what can I conclude? That I can conclude, okay, which carbocation is maximum stable? Option 3 is maximum stable. Next position, see, both are electron withdrawing group 2 and 4, but benzene neither donating nor electron withdrawing, I mean hydrogen. So next position goes to 2. Now what should be the next? Next is option 4, because electron withdrawing but mild, plus R minus I, opposite working. And fourth one is obviously option 2. Why? Because both are withdrawing in nature. So option 3, sorry, this is not 2, this is 1. Option 3, 1, because this is 1. Option 3, 1, 4, 2. This is the overall order of stability of this carbocation based on the substitution at para position. Now one thing, order of decreasing reactivities, means who is maximum reactive for this? Obviously option C. So look at where option C is the first position, option A and B. So option this and this gone. This is called process of elimination, very helpful for solving MCQs. Right now we need to compare between two options, that is helpful. Next position 1, 1. Okay, you cannot conclude here. Now we need to go further. Next position, that 4 or 2. By the way, we have studied just some time before that, okay, NO2 is the most electron withdrawing group, so its rate is minimum. So obviously option A is the right answer. Look at, we found out this option. Now if you get this question in the exam hall, less than 30 seconds, how can you solve? You need to understand that, okay, they are asking this OH to Br conversion, and the carbocation is the intermediate, because SN2 point of view you cannot explain, only SN1 you can explain. Now what is the relative stability? It's a very strong electron withdrawing, it is a donating, it is weakly, so it is donating, so rate will be maximum. Look at option A and option B remains, CD gone by process of elimination. Very helpful here. Now next position, you need to think, okay, who is maximum electron withdrawing in nature in this group? So nitrogen NO2 versus Br, so obviously NO2, because we know NO2 is stronger electron withdrawing. If you forget, then recall the concept. If you consider nitrobenzene cannot undergo aromatic electrophilic substitution. That's why, because it's so much electron deficient, that is the reason it is used as solvent in Friedel-Crafts alkylation acylation reaction. But bromobenzene you can do, relatively drastic condition needed, but you can do, end up ortho and para depending on the situation, aromatic electrolytic substitution. So this is logic, you know. So this is a very high electron withdrawing. Okay, so where it should be the last option, A, here is the last option, so this is the answer. So you need to do this process very quickly, and I assure you less than even 15 seconds you can solve it. But for that purpose, 2 points needed. One is systematic study and second is practice. Do not run blindly behind the tricks. They are helpful when you have enough knowledge. So I believe this video may be useful. Thanks for watching, and if you have any doubt regarding the logo of my channel, please read this part, your doubt will be clear. So see you in my next video. Bye bye.